Hello, in this lecture we will find the size of angle x in two different methods. In the drawing we have quadrilateral SRPQ. We know that angle SRP, this angle equals to 65 degrees. Angle PRQ, this angle equals to 50 degrees. We also know that side PQ, side PS, this side is equal to side SQ. And we want to find out the size of angle PSQ, this angle that equals to x. Okay, so we will start with the first method. We will do a construction. Actually, we will extend side QR by a straight line. And then we will draw perpendicular from point S to the extended QR. So this angle is a right angle, it equals to 90 degrees. And we will define the touching point between the perpendicular and the extended QR as point N. Again, the touching point between the perpendicular to extended QR is defined as point N. And in the next step, we will draw perpendicular from point S. From point S, we will draw perpendicular to PR. So this angle is a right angle, it equals to 90 degrees. And this angle is also a right angle, it equals to 90 degrees. And we will define the touching point between the perpendicular to PR as point N. Then we will calculate the size of this angle. We will define it as angle Z. We actually have a rule number 1. Rule number 1 states that the sum of the angles on one side of a straight line is equal to 180 degrees. So I will read rule number 1 again. Rule number 1 states that the sum of the angles on one side of a straight line is equal to 180 degrees. So actually side QR as the side of a quadrilateral is a straight line. Then we extended side QR in the construction, we extended side QR by a straight line. Therefore, QN is also a straight line. So I write it down that QN is a straight line. Line segment QN is a straight line. Again, line segment QN is a straight line because QR is the side of a quadrilateral that is a straight line, and we extended the straight line QR by a straight line, so QN will remain a straight line. And we have rule number 1 that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we look on the bottom side of the straight line QN and we focus at point R, then according to rule number 1, on the bottom side of QN here at point R, the sum of the angles must be equal to 180 degrees. Okay, this is point R, and the sum of the angles at point R on this side of the straight line NQ must be equal to 180 degrees. That is to say 50 degrees plus 65 degrees plus the size of angle Z must be equal to 180 degrees according to rule number 1. The sum of the angles on this side on the straight line NQ must be equal to 180 degrees according to rule number 1, that is to say 50 degrees plus 65 degrees plus angle Z must be equal to 180 degrees. Here we will subtract from this equality 50 degrees and we will get that 65 degrees plus angle Z will be equal to 180 degrees minus 50 degrees is 130 degrees. So here we will subtract 65 degrees from this equality and we will get that the size of angle Z is actually 130 degrees minus 65 degrees is 65 degrees. So we found out that angle Z equals to 65 degrees. So here we can write that angle Z equals to 65 degrees. Okay. So in the next step we will focus on the right small triangles, the right triangle SMR, the right green triangle SMR, and the right blue triangle SNR. We will actually prove that those two triangles can go into each other. Okay? we will prove that the green triangle congruent to the blue triangle. First of all, so I'll write it down. We will focus on triangle SMR. And triangle SNR. Both of them right triangles, and we will focus we will actually prove that those two right triangles congruent to each other. Okay? So actually SR, this side SR is a common side. It belongs to both triangles. So we can write down that SR equals to SR as a common side. It is a common side. And we actually have another rule. I will not write it down. It is very simple rule that states that the sum of the angles in any triangle is equal to 180 degrees. So if we focus on the right triangle, if we focus on the green right triangle, in this green right triangle, we know that this angle is equal to 90 degrees. Angle SMR equals to 90 degrees. And we also know that angle MRS equals to 65 degrees. Okay, so we have two angles. One angle is 90 degrees and the other angle is also 65 degrees. And we have exactly the same angles in the blue triangle, 90 degrees and 65 degrees. And we know that the sum of the angles in any triangle equals to 180 degrees. Okay, so therefore the third angle must be equal to 180 degrees minus the sum of the two other angles. So it will be equal to 180 degrees minus the sum of these two angles, 90 degrees plus 65 degrees. So here 90 degrees plus 65 degrees is actually 155 degrees. And 180 degrees minus 155 degrees is actually 25 degrees. So we actually found out that the size of this angle is 25 degrees, and it is exactly equal to the size of this angle because they have exactly the same two triangles, the same two angles. This angle is 90 degrees, this angle is 65 degrees, therefore the size of the third angle must be equal to 25 degrees also. So we actually found out that all three angles of the green triangle are correspondingly equal to all the three angles of the blue triangle. Okay? And we also know that SR is a common side. It belongs to both triangles. So we actually proved that the green right triangle is congruent to the green blue triangle. So I'll write it down. the green right triangle SMR is congruent. This is the sign of congruent to the blue right triangle SNR. According to angle side angle rule. Actually, we proved more than we need, because we actually proved that all the three angles of the green triangle are equal to all the corresponding three angles of the blue triangle. And angle side angle rule states that if you have two angles in one triangle and the side that attach to these two angles that are equal to two angles and the side that attached to those and the side that attached to those two angles. So if two angles and the side that attached to those two angles in one triangle is correspondingly equal to the two angles and the side that attached to those two angles in the other triangle, then you actually proved that those two triangles can go into each other according to angle side angle rule. And we actually proved even more than that. We actually proved not only that the two sides that attached to SR in the green triangle are equal to the two angles of the blue triangle, but we actually proved that all the angles in the green triangle are equal to all the angles of the blue triangle. Therefore, we actually proved more than what is needed. And anyway, we proved that the green triangle is congruent to the blue triangle according to angle side angle rule. We have those two angles and the side that attach to those two angles that are corresponding equal to those two angles and the side that attach to those two angles in the blue triangle. Therefore, the two triangles can go into each other according to angle side angle rule. And from the fact that the green triangle is congruent to the blue triangle, we can conclude that side SM in the green triangle is equal to side SN in the blue triangle. So I will write it down. SN is equal to SN. Okay? According to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides will also be equal to each other. Okay? So in the next step we will focus on two right triangles. The right triangle SMR, this right triangle, and the right triangle SNR. And we will prove that those two right triangles can go into each other. Okay? So I'll write it down. We will prove that the right triangle SMP, this right triangle SMP, and triangle, this right triangle SNP, triangle, this right triangle SNQ. Okay? and we will actually prove that those two right triangles can go into each other. Okay? So first of all, we have already proved that SM equals to SN. SM of triangle SMP is equal to SN of triangle SNQ. Okay, SM equals to SN. We also know that SP is equal to SQ. It is given us in the question that SP equals to SQ. So we actually will define SP as Y, and then SQ will be also equal to Y because of the fact that they are equal to each other. So SP is equal to SQ, and it is equal to Y according to our definition. So SP equals to SQ according to what is given us in the question. And we will prove now that PM equals to NQ. Again, we will prove that PM in this right triangle is equal to NQ in this right triangle. Okay, we will prove that PM is equal to NQ. Actually, because of the fact that those two triangles are right triangles, we can implement the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. We will prove that PM equals to NQ. So, if we focus on the right triangle, triangle SMP, according to the Pythagoras theorem, I'll write it down, Pythagoras theorem. In the right triangle, triangle SMP. Again, according to the Pythagoras theorem, in the right triangle, triangle SMP, PM square plus SM square will be equal to SP square. PM square plus SM square will be equal to PS square. Okay? According to the Pythagoras theorem, in the right triangle, triangle SMP, PM square plus SM square equals to PS square. Here we will subtract from this equality SM square, and we will get that PM square is equal to PS square minus SM square. So here we will take a root out of this equality, and we will get that PM equals to the root of PS square minus SM square. So we found out the value of PM according to the Pythagoras theorem. PM square equals to the root of PS square minus SM square. So I write it here again. PM equals to the root of PS square minus Sm square. So we will repeat the same process on the right triangle SNQ. So in the right triangle SNQ, according to the Pythagoras theorem, Sn square plus Nq square will be equal to Sq square. Sn square plus Nq square will be equal to the hypotenuse square, that is actually Sq square. Okay. So here we will subtract from this equality Sn square, and we will get that Nq square is equal to Sq square minus Nq square. We will take a root out of this equality, and we will get that Nq is actually equal to the root of Sq square minus Nq square. Here we subtracted Sn square from this equality, so here we have Sq square minus Sn square. Again, we subtracted from this equality Sn square, so we got that Nq square equals to Sq square minus Sn square, okay? So we took a root out of this equality, and we got that Nq equals to Sq square minus Sn square. So we found out the value of Nq, and we also found out the value of Pm, and actually those two expressions are equal to each other. So we see that they are equal to each other. Pm equals to the root of Ps square minus Sm square. While Nq is equals to S to the root of Sq square minus Sn square. Okay, those two expressions are equal to each other. Why? Because Ps is equal to Sq according to what is given us in the question. Ps equals to Sq. It is given us in the question that Ps or Sp equals to Sq. Ps is equals to Sq according to what is given us in the question. So those two expressions are equal to each other, and actually Sm is also equals to Sn. We have already proved that Sm equals to Sn. Sm equals to Sn. Okay. Therefore, we actually proved that those two expressions are equal to each other. So this expression is actually Pm, and this expression is actually Nq. So we actually found out that PM equals to NQ. PM equals to NQ. So we actually proved that three sides of this right angle are equal, correspondingly equal to three sides of this right angle. Therefore, we proved that the right triangle SMP, is congruent to the right triangle SNQ. It's congruent to the right triangle SNQ. According to side rule. So what is side rule? Side rule says that if you prove that three sides of one triangle are correspondingly equal to three sides of the other triangle, then you actually proved that those two triangles can go into each other according to side rule. And we proved that three sides of this right triangle are correspondingly equal to three sides of this right triangle. Therefore, those two right triangles can go into each other according to side rule. And from the fact that those two right triangles can go into each other, we can conclude that those two angles are equal to each other. Those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding angles, these two corresponding angles will be equal to each other. So I will write it down. So angle SPM is equal to angle SQN. This angle SPM is equal to angle SQN, and if we define angle SPM as theta, then angle SQN will be also equal to theta because of the fact that those two angles are equal to each other. So actually angle SPM is equal to angle SQN, and both angles are equal to theta according to our definition. Okay? So in the next step, I will present to you rule number 2, and we will implement rule number 2 in our drawing. Rule number 2 states that if a line segment subtends two equal angles on the same side, if a line segment subtends two equal angles on the same side, then the quadrilateral is inscribed by a circle and the 4 points lie on that circle. I will read rule number 2 again. Rule number 2 states that if a line segment subtends two equal angles on the same side, then the quadrilateral is inscribed by a circle and the 4 points lie on that circle. So I will actually explain the rule by our drawing. Okay, because in our drawing we have two angles that are equal to each other. Both of them are equal to theta, and those two angles subtend on the segment line SR. This segment line SR. This angle theta subtend on SR, and this angle theta subtend on the same segment line SR. Therefore, according to rule number 2, the quadrilateral SRPQ is inscribed by a circle. The quadrilateral SRPQ is inscribed by a circle, and the 4 points S, R, P, and Q lie on that circle. Okay, so this is actually the implementation of rule number 2 in our drawing, because we have here two equal angles. Both of them are equal to theta, and those two angles subtend on the same segment line SR. Therefore, according to rule number 2, the quadrilateral SRPQ is inscribed by the blue circle, and points S, R, P, and Q lie on this blue circle. Okay? This is the implementation of rule number 2 in our drawing. So we actually have also rule number 3, and rule number 3 states that according to rule number 3, peripheral angles that subtend on the same chord are equal to each other. I will write it down. Peripheral angles that subtend on the same chord are equal to each other. So I will read rule number 2 again. Rule number 3. I read rule number 3 again. Rule number 3 states that peripheral angles that subtend on the same chord are equal to each other. Again, we can implement rule number 3 in our drawing. In our drawing, we have those two peripheral angles, X and angle PRQ, that equals to 50 degrees. Those two angles subtend on the same chord called PQ. Therefore, according to rule number 2, those two peripheral angles are equal to each other. That is to say, X equals to 50 degrees. Again, those two peripheral angles X and PRQ that equals to 50 degrees subtend on the same chord called PQ. Therefore, they are equal to each other, that is to say, X equals to 50 degrees. Okay, so we found out that angle X equals to 50 degrees. Angle X equals to 50 degrees according to rule number 3. And that is the answer to our question. So, in the next step, we will find the side of angle X according to the second method. In the second method, we will do another construction. In the second method, we will extend side SR by a straight line. And then from point Q we will raise perpendicular to the extended SR. And so this angle is a right angle, it equals to 90 degrees because of the fact that this is perpendicular to the extended SR. We will define the touching point between the perpendicular to the extended SR is point M. In the next step, we will extend the perpendicular QM in such a way that Q dash M will be equal to QM. We will extend the QM in such a way that this Q dash M will be equal to QM. This is according to our construction, Q dash M is equal to QM. So we will extend QM until MQ dash will be equal to QM. Then we will join together points R and Q dash by a straight line. And we will join together points S and Q dash by a straight line. Okay. So we actually know that SR is one side of the quadrilateral SRPQ. So SR as a side of a quadrilateral must be a straight line. And then we extended the SR, the straight line SR by a straight line, so SM will be also a straight line. So we write down that SM is a straight line. SM is a straight line. And we have rule number 1 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the straight line SM and we look at the bottom side of the straight line SM at point R, the sum of the angles must be equal to 180 degrees according to rule number 1. So we will define this angle as angle L, and we will get that 65 degrees plus 50 degrees plus the size of angle L must be equal to 180 degrees according to rule number 1 that states that the sum of the angles on one side of a straight line equals to 180 degrees. So the sum of the angles on the bottom side of the straight line SM at point R must be equal to 180 degrees. Okay? So this equality is true according to rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. So here we will subtract from this equality 50 degrees and we will get that 65 degrees plus angle L equals to 180 degrees minus 50 degrees is 130 degrees. Here we will subtract from this equality 65 degrees and we will get that angle L equals to 150 degrees minus 65 degrees is 65 degrees. So we found out that this angle L is actually equal to 65 degrees. Okay? So here QM is perpendicular to SM. Okay? QM is perpendicular to SM. That is to say, QM is perpendicular, it must be a straight line. And then we extended the straight line QM by a straight line. So QQ' will still be a straight line. So we write down that QQ' is a straight line. QQ' is a straight line, and we have rule number 1 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the straight line QQ' on this side of the straight line QQ' at point M, the sum of the angles must be equal to 180 degrees. So which angle we have at this side of the straight line QQ' at point M? We have here 90 degrees plus this angle that will be angle G. So 90 degrees plus angle G must be equal to 180 degrees according to rule number 1. Okay, so I write it down. 90 degrees plus angle G must be equal to 180 degrees. That is according to rule number 1. Okay, here we will subtract 90 degrees from this equality, and we will get that angle G equals to 180 degrees minus 90 degrees is actually 90 degrees. So we found out that the size of angle G is 90 degrees. Okay, so this angle is a right angle, that is to say it equals to 90 degrees. Okay, so at point M we have two right angles. So in the next step we will focus on the right small triangle QMR, and the right small triangle QDesMR. And we will actually prove that those two right small triangles can go into each other. So I'll write it down. We will focus on the right triangle QMR, this right triangle, and the right small triangle QDesMR. So I will repeat again. We will actually prove that the right triangle QMR is congruent to the right triangle QDesMR. Okay? First of all, we know that QM equals to QDesM according to our construction. QM is equal to QDesM according to our construction. So I'll write it down. QM is equal to QDesM according to our construction. QM is equal to QDesM according to our construction. We also know that those two angles are equal to each other. They are both right angles. They are equal, both of them, to 90 degrees. So I write it down. Angle QMR is equal to angle QDesMR, this angle, and both angles are equal to 90 degrees. Angle QMR is equal to angle QDesMR, and both angles are equal to 90 degrees. And we also have this common side. MR is a common side. It belongs to both triangles, so we can write down that MR equals to MR. It is a common side that belongs to both triangles. MR equals to MR. It is a common side. MR equals to MR, it is a common side. So we actually proved that the right triangle QMR is congruent to the right triangle QDesMR according to side angle side rule. So I'll write it down. We proved that those two right triangles congruent to each other according to side angle side rule. I'll write it down. Triangle QMR congruent to triangle QDesMR according to side angle side rule. So what is side angle side rule? We actually proved that those two sides and the angle between them are correspondingly equal to those two sides and the angle between them on the other triangle. So we proved that those two triangles can go into each other according to side angle side rule. So from the fact that those two triangles can go into each other, we can conclude first of all, we can conclude two things. First of all, we can conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding angles, those two corresponding angles will be also equal to each other. So I'll write it down. Angle QRM, angle QRM is equal to angle Q dash RM. So those two angles are equal to each other, but this angle equals to 65 degrees. Therefore, this angle will be also equal to 65 degrees because of the fact that those two angles are equal to each other. So we actually found out that angle QRM equals to angle Q dash RM, and both angles are equal to 65 degrees. And the second thing that we can prove, we can conclude from the fact that those two right small triangles can go into each other, that those two sides are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding angles will be equal to each other. So actually QR is equal to Q dash R. QR is equal to Q dash R according to the rule that corresponding sides in congruent triangles are equal to each other. QR equals to Q dash R. So in the next step, so here, before that, we know it is given us in the question that SP equals to SQ. So we will define SP as Y, and therefore, because of the fact that SP equals to SQ, SP will be also equal to Y. Okay, so in the next step, we will focus on the triangle SRQ, this triangle, and triangle SRQ, this, and we will actually prove that those two triangles can go into each other. Okay, so we'll focus on triangles SRQ, this triangle, and triangle SRQ dash. So I will repeat again. We will prove that triangle SRQs can go into triangle QR dash. Triangle SRQ is congruent to triangle SRQ dash. Okay? Those two triangles can go into each other. First of all, we know that RQ equals to RQ dash. We have already proved that RQ equals to RQ dash. Again, we have already proved that RQ equals to RQ dash. Before that, before that, we will prove that the right triangle QMS is congruent to the right triangle QDES-MS. Okay? Again, we will prove that the right big triangle QMS is congruent to the right big triangle QDES-MS. Again, we will prove that the right big triangle QMS is congruent to the right big triangle QDES-MS. The right big triangle QMS is congruent to the right big triangle QDES-MS. First of all, we know that QM equals to QDES-M according to our construction. Again, QM equals to QDES-M according to our construction. We know that those two angles are equal to each other, they are both equal to 90 degrees. So angle QMR is equal to angle QDES-MR, and both angles are equal to 90 degrees. Okay, angle QMR is equal to angle QDES-MR, and both angles are equal to 90 degrees. And we also have here a common side. MS is a common side, it belongs to both triangles. So we can write down that MS equals to MS as a common side that belongs to both triangles. Again, MS equals to MS as a common side. So we actually proved that the right big triangle QMS is congruent to the right big triangle QDES-MS according to side angle side rule. So I will write it down. The right big triangle QMS is congruent to the right big triangle QDES-MS according to side angle side rule. Okay, we actually proved that those two sides and the angle between them in triangle QDES-MS are correspondingly equal to those two sides and the angle between them in the right big triangle QMS. Therefore, we proved that those two triangles can go into each other according to side angle side rule. From the fact that those two triangles can go into each other, we can conclude that QS equals to QDES-S. Okay, QS equals to QDES-S, and because of the fact that QS equals to Y, then QDES S will be also equal to Y. So QS is equal to Q dash S, and both sides are equal to Y, according QS equals to Q dash S, and both sides are equal to Y, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two big right triangles congruent to each other, therefore those two corresponding sides will be equal to each other. So in the next step, we will focus on triangle SRQ and on triangle SRQ dash, and we will prove that those two triangles congruent to each other. Again, we will focus on triangle SRQ and on triangle SRQ dash, and we will prove that those two triangles congruent to each other. So first of all, we know that RQ equals to RQ dash. We've already proved that RQ equals to RQ dash. RQ equals to RQ dash. We just right now proved that SQ is equal to SQ dash. Both of them, those sides are equal to Y. SQ equals to SQ dash, and both those sides are equal to Y, according to our definition. Again, SQ equals to SQ dash, and both those two sides are equal to Y. And here we have a common side. SR is a common side, it belongs to both triangles. So we can write down that SR equals to SR is a common side that belongs to both triangles. So we actually proved that three sides of triangle SRQ are correspondingly equal to the three sides of triangle SQ dash. Therefore, we proved that triangle SRQ is congruent to triangle SRQ dash according to side rule. So I'll write it down. We proved that those two triangles congruent to each other according to side rule. So I'll write it down. Triangle SRQ is congruent to triangle SRQ dash according to side rule. So side rule is a rule that states that if you prove that three sides of one triangle are corresponding equal to three sides of the other triangle, then you actually prove that those two triangles can go into each other according to side rule. Okay, so from the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other. This angle SQR is equal to angle SQ dash R. I will write it down. Angle SQR is equal to angle SQ dash R. Again, angle SQR is equal to angle SQ dash R according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding angles will be also equal to each other. So if this angle is equal to theta, then this angle will be also equal to theta, because of the fact that those two angles are equal to each other. So we got that angle SRQ equals to angle SQR is equal to angle SQ dash R, and both those angles are equal to theta according to our definition. So in the next step we will prove that angle PRQ dash is a straight line. We prove that angle PRQ dash, if you look from the bottom side of this angle, that angle PRQ dash is a straight line. Actually, first of all, we will prove that PQ dash, or the segment line PQ dash, is a straight line. Again, we will prove that the segment line, this segment line PQ dash, is a straight line. PQ dash so in order to prove that angle PQ dash is a straight line, we will prove that angle PRQ dash equals to 180 degrees. And as you already know, any angle that equals to 180 degrees is a straight line. Okay, so what is the size of angle PRQ? If you look from the bottom side, the size of angle PRQ is actually equals to 50 degrees plus 65 degrees plus 65 degrees. This is the size of angle PRQ from the bottom side. So here 65 degrees plus 65 degrees is 130 degrees, and 130 degrees plus 50 degrees is 180 degrees. So we found out that angle PRQ is angle that equals to 180 degrees. Therefore, we can conclude from the fact that angle PRQ dash, angle PRQ dash equals to 180 degrees, and from the fact that angle PRQ dash is equal to 180 degrees, we can conclude that the segment line PRQ dash is a straight line. Segment line PRQ dash is a straight line. Segment line PRQ dash is a straight line, and again I will repeat that any angle that equals to 180 degrees is a straight line. Therefore, PRQ dash is a straight line. And if PRQ dash is a straight line, PQ dash is also a straight line. So we can conclude that PQ dash is a straight line. PQ dash is a straight line. PQ dash is a straight line, and because of the fact that PQ dash is a straight line, actually the shape PSQ dash is a triangle. Again, the shape PSQ dash is a triangle. PSQ dash is a triangle. PSQ dash is a triangle. So in triangle PSQ dash, in triangle PSQ'. We know that PS equals to SQ'. PS equals to SQ', and both sides are equal to Y. PS equals to SQ', and both those two sides are equal to Y according to our definition. PS equals to SQ', and both those sides are equal to Y. And we actually have a rule that states that in front of equal sides in the triangle there are equal angles. So in front those two equal sides there will be equal angles. So those two angles are located in front of those two sides that are equal to each other. Therefore those two angles that are located in front of equal sides will be also equal to each other according to the rule that I stated. But we know that this angle equals to theta, so this angle that equals to this angle will be also equal to theta. Okay, so we arrived to a point that is exactly as method 1. We have here two equal angles. Both those two angles are equal to theta, and those two angles subtend on the same line segment SR from the same side. Therefore, according to rule number 2 that I mentioned in method 1, the quadrilateral SRPQ is inscribed by a circle, and the 4 points S, R, P, and Q lie on that circle. Okay? So, actually, this is the implementation of rule number 2 in our drawing. We know that those two angles that equal to each other subtend on the same line segment SR. Therefore, according to rule number 2, the quadrilateral SRPQ is inscribed by a circle, is inscribed by this blue circle, and the 4 points S, R, P, and Q lie on this circle. Okay? And I mentioned also rule number 3 in method 1, the first method. According to rule number 3, peripheral angles that subtend on the same chord are equal to each other. So we actually have those two peripheral angles, angle X and angle PRQ, that equals to 50 degrees. They both those angles subtend on the same chord PQ. Therefore, according to rule number 3, they are equal to each other. That is to say, X equals to 50 degrees. So we can write down that X equals to 50 degrees. Okay? So, in the next step, I'll summarize the lecture. So, we actually in method 1, we did a construction in order to find out the size of angle X, this angle, and the construction was that we actually extended side QR by a straight line until point N. Then from point S we draw perpendicular to the extended SR to QN, so this again equals to 90 degrees. And then we draw another perpendicular from point S to PR. So this angle is 90 degrees and this angle is also equals to 90 degrees. And then I presented to you rule number one. Rule number one states that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so here we have QR is one side of quadrilateral SRPQ, therefore it must be a straight line. Then we extended the straight line QR by a straight line, so QN will still be a straight line, and we calculated the size of this angle according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line QN at point R, the sum of the angles must be equal to 180 degrees according to rule number one. That is to say 50 degrees plus 65 degrees plus the size of this angle is we defined it as angle Z equals to 180 degrees according to rule number one. So we solved this equation and we found that Z equals to 65 degrees. So this angle equals to 65 degrees. So then we actually proved that the green triangle can go into the blue triangle. We know that SR equals to SR. It is a common side that belongs to both triangles, to the green triangle and to the blue triangle. Okay? And then we know that the sum of the angles in any triangle is equal to 180 degrees. Here we have this angle equals to 90 degrees. This angle is equal to 65 degrees. In total, those two angles are equal to 155 degrees. And we know that the sum of the angles in any triangle is 180 degrees. And we have already two angles that the sum of them is 155 degrees. So this angle must be equal to 25 degrees in order to complete the sum of the angles in the triangle to 180 degrees. And the same thing is about the blue triangle, because they have exactly the same angles. So those two angles are equal to each other and they are both equal to 25 degrees. Those two angles are also equal to each other, they're equal to 90 degrees. And those two angles are equal to each other, they're both equal to 65 degrees. So we actually proved that the green triangle can go into the blue triangle according to angle side angle rule. We have one side that is a common side, and we have the two angles that attach to this side in the green triangle that correspond equal to the two angles in the blue triangle, and the side, the two angles and the side that attach to the two angles in the blue triangle. So therefore those two triangles can go into each other according to angle side angle rule. From the fact that those two triangles can go into each other, we can conclude that SM equals to SN. Then we focused on the right triangle, triangle SMP, on the right triangle, triangle SNQ. We proved that those two right triangles can go into each other. First of all, we just right now proved that SM equals to SN. We know it is given as the equation that SP equals to SQ. SP equals to SQ. And we proved that PM equals to NQ. So why PM equals to NQ? Because actually we have right triangles, so we can implement the Pythagoras theorem in those two right triangles. The Pythagoras theorem states that the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. So in the right triangle SMP, PM square plus SM square equals to SP square. So PM equals to this expression, and in the right triangle SNQ, according to the Pythagoras theorem, NS square plus NQ square equals to SQ square. So NQ equals to this expression, and those two expressions are equal to each other. SP equals to QS and SM equals to NS. Therefore, this is PM and this is NQ. Therefore, we got that PM equals to NQ, and we actually proved that those two right angles can go into each other according to side rule, and from the fact that those two triangles can go into each other, we concluded that those two angles are equal to each other. So if one angle is equal to theta, then the other angle will be also equal to theta, because of the fact that those two angles are equal to each other. So then I presented to you rule number 2. Rule number 2 states that if a line segment subtends two equal angles on the same side, then the quadrilateral is inscribed by a circle and the 4 points lie on that circle. So here we have actually two angles that are equal to each other, both of them are equal to theta, and those two angles subtend on the segment line SR. Therefore, according to rule number 2, the quadrilateral SRPQ is inscribed by a circle, and those 4 points SR, P, and Q lie on that circle. Okay, again, because of the fact that those two angles are equal to each other and both of them subtend on the same segment line SR, then according to rule number 2, the quadrilateral SRPQ subtend, the quadrilateral SRPQ is inscribed by the blue circle, and the points SR, P, and Q lie on this circle. And we also have rule number 3 that states that peripheral angles that subtend on the same chord are equal to each other. So here we have two peripheral angles that subtend on the same chord PQ, therefore they are equal to each other. That is to say, X equals to 50 degrees. Okay? Then we have also the second method. We found out the side of angle X according to the second method. In the second method we did another construction. In the second method we actually extended SR by a straight line, and from point Q we raised perpendicular to the extended SR. This angle equals to 90 degrees, and then we extended QM in such a way that Q dash M will be equal to QM. Then we calculated the size of this angle is equal to 90 degrees according to rule number 1, and the size of this angle is also equal to 65 degrees according to rule number 1. Then we proved that those two triangles can go into each other according to side angle side rule. Therefore, if this angle is 65 degrees, this angle is also 65 degrees, and those two sides are also equal to each other. And then we proved that the right big triangle QMS can go into the right big triangle QDS according to side angle side rule. From the fact that they can go into each other, we concluded that those two sides are equal to each other. Then we proved that those two triangles can go into each other according to side rule, and from that fact we actually proved that those two angles are equal to each other. And then we proved that PQ dash is a straight line, therefore PSQ dash is a triangle, and in this triangle we have two sides that are equal to each other, and according to the rule that in front of equal sides in the triangle there are equal angles, those two angles are equal to each other, so if this angle is theta, this angle is also theta. Then we have those two sides, those two angles that are equal to each other, and subtend on the same segment line SR. Therefore, according to rule number 2, the quadrilateral SRPQ is inscribed by a circle, and the 4 points SRP and Q lie on that circle. Okay, and we have also rule number 3 that states that in front of equal, rule number 3 states that peripheral angles that subtend on the same chord are equal to each other, and we have those two peripheral angles that subtend on the same chord. Therefore, x equals to 50 degrees. Those two peripheral angles subtend on the same chord PQ, therefore angle x equals to angle PRQ that equals to 50 degrees. That is to say angle x equals to 50 degrees. Okay, thank you very much.